Well, thank you everyone for joining this. And it is a little bit late in Bangkok. However, I hope that I have enough adrenaline to talk about something that I'm quite interested in and something that I think is really important to stay awake for the 30 or 40 minutes that it takes to go through this. So this is something that everybody needs to do, whether you're managing the golf course turf or the football turf or lawns. We need,
Micah,
yes.
sorry, just 1 second. If there are attendees that are listening just in English that don't understand Spanish, there are in the session in the documents box there is the slides in English. So if you want to download it in order you can attend the presentation in English, in both listening to Mike in English and watching the slides in English, you can do it. Just that, Micah, sorry. Thank you.
Yeah, that's correct. In fact, if you go to blog.asianturfgrass.com, you will find the latest post has the slides in English and the slides in Spanish that you can click through. So hopefully people will be able to choose the audio channel they like and then see the slides that they like also. Okay, I'm going to continue. So this is all about preventing nutrient deficiencies, and then as a side effect, kind of as an accident, I think it might surprise some people, but if we are very careful about preventing nutrient deficiencies, we can actually end up as a result using less fertilizer. So that's what we're going to talk about. And I'm going to divide this into 4 points. And the first one is about how we can prevent the nutrient deficiencies by considering how much the grass will use. So we consider how much of each nutrient the grass will use, and we make sure that that's supplied. And then the second point is we'll talk about how we can use soil tests. And then we'll talk about, in the context of soil tests, how we can use specifically the MLSN guidelines. And finally, at the end, I will show how when this all comes together, we end up supplying 100% of what the grass can use to prevent deficiencies, and a result of that is we can actually use less fertilizer. It's kind of interesting. So the very first section that we're going to get started with, we're going to talk about preventing deficiencies by estimating how much the grass can use and making sure that it's supplied with all that it can use. I'm going to have a quick drink of water. So I want you to think about something as far as how much the grass uses. It's really related to the growth rate. Something that's unique with the grass is we're constantly mowing it if it's growing. So if it's growing rapidly and we're mowing it, we cut away nutrients. We cut away leaves and we take away nutrients. If it's growing quickly, it uses a lot of nutrients. If it's growing slowly, like this turf in Hawaii, it won't be using very many nutrients at all because we won't be mowing it very much. The grass leaves are not extending. It doesn't use very many nutrients. So when we think about the nutrient use, it's really related to the growth rate. I've written about this extensively in my book, The Short Grammar of Greenkeeping. I put the link to it here. And I've also written about this extensively on my blog. So I think many people will have read or have been to one of my seminars and heard me talk about the importance of the growth rate. So much of what we do in greenkeeping or any kind of turfgrass management is trying to establish the growth rate, and that growth rate really determines how much nutrients the grass will use. If you consider, for example, this turf, if it's growing quickly, it's going to use more nutrients. If it's growing slowly, it's going to use less nutrients. It's as simple as that. The quantity of nutrients that the grass uses is directly related to how much it grows. And so we want to get to a way where we can figure out how much of each nutrient is the grass using. So one thing we could do is actually measure all of the clippings that we collect. But actually, I think in some cases this is useful. I wrote about it a little bit in the handout, which I hope everyone will read. But if you think about it, probably for many places and certainly for large areas, we cannot collect all of the clippings. We can't directly measure it, but there's a little bit of a trick that we can use, because I think that we're dealing here with professionally managed turf. We're not dealing with bad turf or with amateurs taking care of it. We're dealing with professionally managed turf. And when the turf is managed by professionals, the growth rate of the grass is really determined by how much nitrogen we supply. So we can estimate how much it will grow based on how much nitrogen is supplied. For example, if we have agrostis, creeping bentgrass, and we supply 15 grams of nitrogen per square meter per year, that's the unit that I like to use. You might prefer kilograms per hectare or kilograms per 100 square meters or something, but I like grams per square meter, so that's what I'll use throughout this presentation. If we have that quantity of nitrogen supplied to agrostis, then that puts an upper bound on the amount of nitrogen that the grass will use of 15, and then because we have healthy grass, we want to make sure that the grass is supplied with enough of each nutrient to produce healthy grass, so we can look at what those normal nutrient ratios are in healthy bent grass, and we can see that when we use 15 grams of nitrogen, we use 7.5 grams of potassium, 1.9 of phosphorus and calcium, 0.8 of magnesium. So we can, just from the nitrogen, we can get an estimate of how much of each of the other elements the grass will use. This is different for different grasses because different grasses may have different ratios of the elements in the leaves. If we put 10 grams of nitrogen to seashore paspalum, now it's going to use the same amount of potassium, 10 grams also, and 1.7 of phosphorus, 1.7 of calcium, and so on. So based on the quantity of nitrogen that is supplied to the grass, that puts an upper estimate of how much the grass will grow or how much nitrogen it will use, and then based on what is in healthy bentgrass or seashore paspalum or cynodon leaves, which is what we're trying to produce, we can get an estimate of how much of each of those elements the grass will use. Here it is for cynodon. We get a slightly different ratio. Now it's 3 parts of nitrogen to 2 parts of potassium. So if we put 20 grams of nitrogen to Bermuda grass, to cynodon, we would have an expected potassium use of 13.3 grams. Phosphorus 3.3, magnesium 1.3. That's if we already know how much we're going to apply, but there's another way we can estimate this. We can use something called the temperature-based growth potential, and I've written a couple of articles about this. This is one from, I believe, the April 2013 issue of Greenkeepers magazine, which is also in the handouts, and you can download it. And in English, I've also made this available, a different article about this topic available for download. So if you, for some reason, don't have any idea how much nitrogen to apply, you can quickly calculate a rough estimate using growth potential. And some other cases when you might want to do this, maybe you get a new job in Bogota or a new job in Kathmandu, and you want to say, and you've never been there, and you want to know how much the grass may use in those locations, well, you can check the weather, the temperatures, and make an estimate. Or maybe you want to change grasses. Different grasses have different growth rates, different amounts of nitrogen used, so you can use growth potential to compare what would happen if you change from one grass to another at the same location. Or another thing you might like to do, and this is kind of the basis of what I call the grammar of greenkeeping, is to compare from place to place. So for example, maybe we go to Orlando and see some beautiful greens at the Golf Industry Show at a golf course we visit there, and let's say that's Tiff Eagle Bermuda grass, and then we want to go back to, let's say we want to go to Guangzhou, China, or Hong Kong, China, and and manage TIF-Eagle in exactly the same way. Well, in order to apply exactly what's being done in Orlando, to apply it in another place, we can use the growth potential. So I calculated this for Las Palmas, and for Seashore Paspalum at Las Palmas, I calculated estimated nitrogen use of 12.4 grams of nitrogen per square meter. And that's based on this growth potential curve for warm season grass, which is based on temperature. So we take the growth potential for each month. You see that it ranges from 0 up to 1. In this case, it ranges to about 0.66 as a maximum. And you multiply that amount times the maximum nitrogen that you may apply in 1 month, and that gives you an estimate of how much the grass may use. So simply based on temperature, we can get an annual nitrogen estimate of 12.4 grams, and then with Seashore Paspalum, we know it'll use the same amount of potassium, and we can also get estimates for the other nutrients. We can also go to Valencia. I calculate in Valencia for cool season grass, for agrostis, we get an estimate of 22 grams of nitrogen, because there's 8 months in the year at Valencia that have a growth potential of 0.5 or above. So Valencia has a pretty nice climate, although it does get rather hot in the summer for bent grass, but it will still keep growing well. So in Valencia, and I'm going to use this for an example later, we get a nitrogen use estimate of 22 grams, and that leads to potassium of 11, phosphorus of almost 3, calcium almost 3, magnesium about 1. So whether we know exactly how much we apply, or whether we just want to calculate it for a place, we're able to get some kind of number to estimate how much healthy grass is going to use at that location. Now, you may notice that I haven't talked about micronutrients at all. I've only been talking about nitrogen, potassium, phosphorus, calcium, and so on. Why am I not talking about micronutrients? Well, there's a good reason, because if you look on this chart, I've shown on the y-axis from 0 to 40,000 parts per million, this is the concentration of nutrients in healthy grass leaves, and this is based on data from Pennsylvania State University. I put the link at the bottom of the slide that shows where you can find that data. It's an excellent guide, I think a professional turfgrass manager's guide to fertilization, they call it. And this is the normal nutrient levels in healthy leaves. And you see, it's got almost all the essential elements listed there, but when you get over to the micronutrients like manganese and iron and zinc and boron and copper and molybdenum, you'll notice the quantity in the leaves is indistinguishable from 0. When we show it on the same scale as the macronutrients like nitrogen, potassium, calcium, and so on, the micronutrients are indistinguishable from 0. And this is actually, sometimes I think it's difficult to think in terms of parts per million or percent. So I thought of something that everybody's familiar with, which is money. And I said, let's represent these data. Let's say we have a $50,000 fertilizer budget. If we have $50,000 or 50,000 euro that we're going to spend on fertilizer, and if every element costs the same amount of money, then this is how the nutrients are used by the grass. The grass would use almost $24,000 worth of nitrogen. It'd use $12,000 worth of potassium. And you get down to the micronutrients, manganese is $58. And that's the most expensive one. All the other micronutrients, they're all less than $60. So here's my thinking about micronutrients. Of course, every element's important. They're all important. We don't want deficiencies in any of them. But when it comes to micronutrients, the amount that the grass uses is so small that it's very likely the grass can get that amount from the soil. And even if it can't get that amount from the soil, the amount that it uses is so small that the relative cost in terms of fertilizer is minuscule. So I think if you think you might have a problem with micronutrients, just apply them. You can apply all that the grass can use, or you can apply twice the amount that the grass can use, or 3 times the amount that the grass can use. It's going to cost you almost nothing, and you can feel happy. But probably you don't even need to apply. So here I've calculated now for all the elements for Valencia, and you can see it's the same. Nitrogen is at 22, and then going down, potassium's 11. When you get down to the micronutrients, iron is 0.06 grams. This is estimated use for 1 year. This is grams per square meter. And so you'll see all of them are less than 1/10 of 1 gram per square meter, or what would that be? 100 milligrams of element per square meter. So the micronutrients are used in such tiny amounts that I really just don't worry about them. If you worry about them, you can apply a little bit and supply all the grass uses. And I want you to remember these because, well, remember the potassium and phosphorus, or remember where these numbers came from. We're going to call this amount A. So I'm going to work through a calculation later for Valencia, and we'll use this these numbers, and we'll call this amount A, which is the amount that the grass can use. And so that leads us to soil test data. So I've showed a couple different ways to calculate how much the grass can use. We'll call that amount A. And I want to tell you a little secret here. It kind of doesn't matter. Well, let me phrase it this way. If you don't get the calculations exactly right in the first section, it doesn't matter, because when you do soil testing, you can catch it and you can make corrections. So how do we use soil test data? Well, I want to explain how I think it should be used. It's important to understand and not be confused about this. The main reason, the purpose of soil testing is to determine how much fertilizer to apply. And that's really why we want to soil test. So we've just calculated the amount A. I'm calling it A, which is the amount that that the grass will use. If we don't do any soil testing, then we could just apply the amount A, which is 100% of what the grass will use, and we don't need to soil test. But if we soil test, we can find out if the soil can supply some of the nutrients that the grass would use, and in that case, it makes sense to subtract the amount that the soil can supply from the amount A that we want to supply, or the amount A is the amount that the grass will use. So I'm going to show in the next couple of charts why we don't have to get that A value exactly right. Because if we analyze the soil every year, we can just check and see if the nutrients are going up or going down. So this is some simulated data for 7 years for potassium. And in this case, you can see that it starts in 2010 at about 50 parts per million in the soil, and it goes up to 2016 to about 75 parts per million in the soil. What you see over time is the soil potassium is going up. So what you can tell, if it's going up, that means the grass is using less than is being applied as fertilizer, or that's coming in the irrigation water, or whatever the source of the potassium is. There's a little bit more being applied than is being used. And this is the opposite case. in this case, we see the potassium is going down over time. It starts off in 2010 at about 65 parts per million, and it goes down to 2016 to be at about 50 parts per million. So in this kind of case, we can say the soil test level of potassium is going down. So you would check this for every nutrient, but as the soil test is going down, that means the grass is using more than is being supplied, and at some point, if you don't supply more, you might run out. And because of that, if you soil test every year, you can be a little bit off as long as you're above the MLSN guidelines or above some kind of safe guideline. You can be a little bit off in your calculation of A, the amount that the grass will use, and you quickly correct it when you check your soil test because you'll see if you're going up or you're going down. Now, I want to use some data from the Global Soil Survey to estimate what soil test values would be. So these are the locations from the first 2 years of the Global Soil Survey, which we did from 2013 to 2015. And we asked turfgrass managers from around the world to submit samples from good performing turf at their locations. They submitted soil samples from those locations, so they all had good performing turf, and then we analyzed them to find out in the modern era, not in the 1960s, not in the 1970s or 1980s, but in the modern era, what are the nutrient levels under the turf in the soil where good high quality turf is being produced. So here's some median values. The average value represented as the median for the macro and secondary nutrients. Potassium was at 61 parts per million in the Global Soil Survey. So half the samples were less, half were above. Phosphorus 71, calcium 623, magnesium 84. We'll call this value C. So we're going to do a calculation coming up for Valencia, and remember these values, the value C, I'm just going to say let's assume that the soil test level was at the median, right in the middle of the Global Soil Survey, which I think is an excellent estimate if I don't have any other information. So here's an equation or a general expression to explain how we calculate the fertilizer. So we get going with this now, and in general, I like to think of it as we take the amount we need and then we subtract the amount we have, and the difference is the amount we have to apply as fertilizer. So we take the amount we need, subtract the amount that's present, the amount that we have, and then the difference between them is the amount to apply as fertilizer. The level A is one amount that we need because I'm calling it A. That's the amount that the grass will use. So that's the amount that we need, and then the amount that we have I'm calling C, which is the soil test amount. The amount that we have is the soil test amount. So if we don't do any soil testing whatsoever, we can just apply A. We can just apply our estimate of how much the grass will use. Because if you apply 100% of what the grass will use, you won't have a deficiency. But once we do soil testing, it gets a little bit, we need a little bit more, because once we have a soil test and we want to use soil testing, we need to know what's the amount that we need to keep in the soil, or what's the amount that we need to keep as a reserve or as a buffer. And that's where the MLSN guidelines come in. So now we move on to the third part of this presentation. I'll show how we can make use of the MLSN guidelines. The MLSN guidelines serve as a minimum level that we don't want to drop below. So we want to keep the soil above the minimum levels given in the MLSN guidelines. And in that way, they act like a buffer of nutrients that we never touch, or they act like a reserve of nutrients in the soil that we never touch. And we're going to call this B. We'll call this amount B. So we've got A is the amount the grass uses, B is the the MLSN guidelines, and C is the soil test amount. I've, of course, written a number of articles about this also. This is an article from January 2014 in Greenkeepers magazine. And I've written about this in English also and on my blog, and you can find links to these articles in the handout. So we'll take this equation now and we'll completely fill it out. The general idea, if you think of it, is the amount we need minus the amount we have. The difference between those is the amount we need to apply as fertilizer. So we've got the amount A, I'm calling A the amount that the grass will use, but we want, if we're using soil testing, we want to keep some in reserve. We want to make sure that there's a buffer of nutrients in the soil, and that's essentially what the MLSN guideline is. So what we're going to do, we're going to add the MLSN amount to the amount we need. So we're going to have the amount the grass uses plus this safety buffer, or this amount that we want to make sure remains in the soil. So we'll add A and B together, and then we'll subtract the soil test amount C. So we have the amount we need is the use of the grass plus the MLSN guideline. That's the amount we need. We subtract from that the amount that's in the soil from the soil test, and the difference between them is the amount required as fertilizer. And the MLSN guidelines are in Malick 3 soil testing method. And sometimes a question comes up, well, I don't have Malick 3 soil test data. What can I do? And here I'm going to give 5 options of what you can do. First, you could actually get some Malick 3 soil tests. It's not difficult, and it's not too expensive. However, if you have soil tests from a different type of method, you can actually convert it. It won't be exact. There's some error introduced when you use these conversions, but there's equations that allow you to convert some common soil testing methods to Malick, estimated values in Malick 3. You can search for that on Google. Or maybe you have some local minimum level. You have calibration at your local state or country for a different soil test method, and you already know a different level that you don't want to drop below, or you want to make up your own minimum guideline. You can just use your own number for B, and then your soil test data C will be with the same method, and you'll be fine. Or you could just skip the soil testing altogether and just apply 100% of what the grass will use. Just apply A. That's something else you could do. Or the fifth option, just do something that I haven't even thought of, do something completely different. So that's your options if you don't have Malick 3 data. And I would like to ask you to think about this. I mean, basically, you can do this however you like, but if you're applying much more than the grass can use, or if you're applying much more than is calculated when you use the method with the MLSN guidelines, I think it would be a good idea to ask yourself, why am I applying more than the grass can use? And I'd also like you to remember this. When you apply fertilizer, you don't at the same time increase the nutrient holding capacity of the soil. Fertilizer is fertilizer, soil is soil, and the nutrient holding capacity of the soil doesn't change when you add fertilizer. So if you're adding a whole bunch of fertilizer over time, thinking that you're going to make some long-term changes in the quantity of nutrients in the soil, sure, you get some small changes, but to make big changes in the soil by applying fertilizer, that's just not the way that it works. So let's go back to our example in Valencia, and so we've got our values A, which I calculated that we put 22 grams of nitrogen. From that, we can figure out how much of the other elements we'll use. The values B come from the MLSN guideline, and the values C are the soil test results, which I'm using the median value from the Global Soil Survey, just because I figure that's a normal soil for turf grass around the world. Here's our nutrient use amounts, the A amounts here. Remember, for Valencia, I calculated we'd be about 22 grams. This is just an example, but it shows how we can make a site-specific. It's not like you have to apply this much. You can apply less, you can apply more, but once you know how much you apply, from that you can calculate your site-specific expected nutrient use. And then, of course, you plug in your own soil test data if you have it also. So we'll go to the next table. So now we've got the A values, the B values, which are from the MLSN guideline, the C values, which are the median from the Global Soil Survey. And if we take A plus B minus C, then we get F, which is the fertilizer requirement. And you can see that it recommends using this method 7.4 grams of potassium per square meter, no phosphorus, no calcium, and no magnesium, because those are all negative, which means the amount that we have is much more than the amount we need, particularly in the case of calcium, which is normal because soils generally contain a large amount of calcium. So in this way, you can compare the amount that you have to the amount that you need, and you can make sure that you're preventing deficiencies. And I want to make a couple notes here, so I've written quite a bit on this slide. The values A I showed where we calculated those from. The values B, you might say, wait a second, potassium I thought was in ppm, and how do you suddenly get this into grams per square meter? Well, of course, if we're going to add things and subtract things, they all need to be in the same units. So we account for the depth of the root zone and the soil bulk density, and then we can use a conversion factor of 6.7. And that's if we're going to use units of grams per square meter. You can read in the handout more about this, and you know, depending on what units you're using, what your root zone depth is, you need to make your own conversion factor. But in that way, you can convert between nutrients in the soil, which are in a three-dimensional space, and nutrients applied to the surface, which are in a two-dimensional space. You'll notice also I didn't put micronutrients on here at all because probably the grass can get all that it needs from the soil, and if it can't, they cost almost nothing. So if it makes you happy, you can just apply that amount. Now we come to the final section where I will show how, one more thing I want to show here from the previous slide. This amount, the 7.4 grams of potassium per square meter, this is an annual rate because I don't really talk about time in here, but if you think about it, when I've calculated how much nitrogen the grass will use, that's an annual amount of nitrogen. And then when we go back and calculate the potassium and phosphorus and calcium and so on from based on the nitrogen, it's all annual amounts. So there's a time embedded in here. We can calculate this on a monthly basis, on a daily basis, on a weekly basis, and I'm doing this on a yearly basis. So this amount is how much is recommended for the next year. So ideally, you divide that into multiple applications and apply it in small doses. So we come to the final section, and I'm going to show how if we very carefully calculate how to prevent the nutrient deficiencies, we end up using less fertilizer, which I think might be or we get lower fertilizer recommendations. And I think that might be a surprise to some people. I'm going to use here, I'm going to simulate a big picture scenario. I'm just going to imagine a situation in Barcelona. Let's imagine, I'm going to imagine there's 1,000 bentgrass putting greens in Barcelona, 1,000 agrostis greens. Now, I don't think there's quite that many, but just bear with me. This is a simulation. Let's imagine that there are 1,000 bentgrass greens, and we're going to fertilize them in 3 different ways. So there's 1,000 agrostis greens. I pick only one location because I want to make sure that we have the same nutrient requirement. So the value A will be the same. I use the growth potential to predict nitrogen use in Barcelona. It comes to 20.7 grams per year, per square meter. In that case, if bentgrass is using that much nitrogen, then I expect it will be using, healthy bentgrass will be using 10.4 grams of potassium per square meter per year. So each of those greens is going to have a potassium requirement of 10.4. And then I don't know what the soil test levels are, but I think it's reasonable to assume that the distribution of potassium in those soils, in those 1,000 greens, is something like it is in the Global Soil Survey. And then we will calculate, so based on different soil test levels for potassium, and all of those greens having a requirement of 10.4 grams, we'll calculate the fertilizer requirement F using 3 different methods. We will calculate it using the MLSN guideline. We'll calculate it without soil testing at all and just apply the amount the grass requires, A. And we'll also calculate it using a conventional guideline of 117 parts per million potassium. So here's 1,000 greens. Each one of those little black dots is a single green. It's the potassium in a single green. This is simulated based on how the soils are in good performing turf as measured in the Global Soil Survey. So in the Global Soil Survey for potassium, most of the samples were less than 100, less than 150 parts per million, but some of them go all the way up to 200, 300. It's not impossible even to have some at 500 or 600 parts per million. If you remember, the median value in the Global Soil Survey was 61 parts per million. So what I've done here is simulated 1,000 putting greens and then piled up all those black dots at the point where that green was at. So these are 1,000 greens piled up, and a lot of them are around 60, 70, 80. That's where the peak is, but they're distributed from 0 to 600. This is those same data, and now it's in bins. So each one of these bins is 10 ppm wide. So from 0 to 10 parts per million, there's about 3 samples. And then from 10 to 20 parts per million, there's about 22 greens. And you see the peak is in the range of 50 to 60, 60 to 70, 70 to 80. There we have over 130 greens in each one of those bins. And then we come out to 580, there's another one, but there's not very many. So this is a histogram of how the soil tests in those 1,000 simulated greens are. And here's the result of what happens when we calculate the fertilizer requirement using the MLSN guideline on those soils. I want you really to pay attention to the median recommendation. So of those 1,000 greens, the median recommendation for potassium is 6.5 grams per square meter. And you see about 180 of the greens got 0 recommendation. But there's a recommendation all the way up to some of the greens get as much as 15 grams of potassium recommended. So the MLSN guideline is recommending something specific to each green, But please notice the median value is 6.5. Then in the second scenario, we're just applying we're ignoring the soil and we just apply what the grass uses. So in this case, every single one of those samples, all 1,000 of those greens get exactly the same recommendation. So 1,000 of the greens are getting recommended 10.4 grams, which is the amount that the amount A that we predict the grass will use. And here is the third way, using a conventional guideline, trying to keep the soil from dropping below 117 parts per million. In this case, the median value is almost 3 times as much as it was. The median recommendation is more than 18 grams. And if you remember, I think it was 6.5 grams if you used MLSN. There's still 40 of the greens get a recommendation of no fertilizer, but the median value is almost 3 times higher than it is if you use the MLSN guideline. And what you notice also, I'll go back one slide. I'll go back 2 slides. So MLSN is 6.5 recommendation. We're applying 100% of what the grass can use. This is the equation A plus B minus C. So we're taking the value A, which is our estimate of how much the grass will use, the value B that we want to keep as a buffer in the soil, and we subtract from that the amount present, and we get this value. If we ignore the soil, we apply more fertilizer. Now the median value is 10.4, and if we use conventional methods, we have almost 3 times as much. So that's how you can prevent nutrient deficiencies by calculating exactly or making an estimate as best you can of how much the grass will use. And then if you use the MLSN guidelines, you can also be able to supply fertilizer in the amount that's 100% of what the grass can use, preventing deficiencies, and at the same time using less fertilizer. So you can find more information, these presentation slides, a 4-page handout, and other articles on my blog, which is blog.asianturfgrass.com. So thank you so much.
Okay, thank you very much to you, Micah. It has been a great presentation and very interesting. I love listening to you. You're a great speaker. Thank you very much. So there is one question from Felix Fernandez. He's a guy from Spain. He says, there is one factor that I think has a lot of importance in what you have talked about, and it's pH. How do you take it into account? The pH can block nutrients that I have in the soil, and however much we replace it, it cannot be assimilated by the plant. What do you think about it?
That's a good question, and it's one of the common questions that I answer on my blog is about what about availability? So instead of, I've just been talking about amounts, but once we start talking about pH, I think what people mean is maybe at a certain pH the nutrients are less available. The easiest way that I would answer this is say, I'm pretty comfortable that if the soil pH is in the range of 5.5 at a minimum up to 8.3 at a maximum, I'm pretty comfortable that we're not going to have too many big problems with nutrient availability. And once we get outside of those ranges, I might be looking to adjust the pH. Certainly, there's the simple one is micronutrients. So maybe in the pH of like 7.5, 7.8, 8.2, it's probable that you would get a better response to some micronutrients than what I've implied in this presentation.
Okay. Another question from Bridget Barry. What is the ratios for POA annua?
Good one. I think most cool season grasses are very similar to bent grass, although okay, the ratios will be similar. So you'll generally have half as much potassium as you do nitrogen. You'll generally have 1/8 as much phosphorus as, I'm sorry, I might have misspoke previously. You'd have half as much potassium as nitrogen. You'd have 1/8 as much phosphorus as nitrogen. You'd have 1/8 as much calcium as nitrogen, and you'd have 1/20th as much magnesium as you would nitrogen. If it's POA annua, POA pratensis, you might have a little bit higher nitrogen. So instead of using like a 4% number in the leaf, you might have 4.5%, maybe a little bit more. And if it's fine fescue, I think Festuca rubra, you would have a similar ratio, but your nitrogen might be a little bit lower. So instead of 4%, you might be in the 3s.
Okay. There is another question. Let me read it. In which way may the pH affect to these minimum values? For example, if we have a pH close to 8?
I don't think it matters because keep in mind that when we're looking at these minimum values, if you saw, the first thing that we do is calculate how much the grass will use, and then we want to supply that. So, of course, if the soil is really high in something, then once we subtract that, it doesn't get recommended as fertilizer. But let's think about the macronutrients one by one. We're dealing with a pH of 8, I believe. So in that case, potassium is not going to be affected by pH. Phosphorus, a little bit will be affected by pH. However, the MLSN guidelines are conservative. Probably the real minimum is something like 7 or 8 parts per million, and we recommend staying at 21 or above. So we think that there's plenty of leeway to still be safe if you keep above the MLSN guideline. And then for calcium in a calcareous soil, the soil, I mean, the reason the pH is high is because there's a lot of calcium there. And when there's a lot of calcium there, there's almost certainly a lot of magnesium there also. So as far as the MLSN guidelines go, they're not really affected much by pH, but you would want to check and see if you get a response from micronutrients, because it may be that you get a better response from applications of micronutrients when your pH is higher. And the MLSN guidelines don't really address that.
Okay, another question. Is there a fear of falling off the map, so to say, during mid-season?
I think that's an excellent question. And if you really mess up your calculations, yeah. But I think once you understand what you're doing, there's tremendous assurance that you're not going to fall off the map. The only situation where I think you could have a problem mid-season would be like, let's say we have a brand new putting green that's high in sand and very low nutrient holding capacity, and we've put a tremendous amount of fertilizer on it, so it has during the grow-in. So the potassium levels and the phosphorus levels and the calcium levels get inflated. And then we do a soil test and we think that that's what's there. And then we get a lot of rain and the soil changes tremendously because we haven't really soil tested what it really is. In that case, there's a few special cases where you could you could run into falling off mid-season. But I think if you pay attention to what the numbers mean and why you're getting certain values for A, B, and C, you can be quite confident that it won't drop off mid-season.
Perfect. Another one. Would you recommend to utilize your irrigation watch in the soil testing, saturated based?
No, I don't. I think it's useful. I mean, everybody should test their irrigation water, and specifically, you want to know the salt content of the water. You want to know the sodium adsorption ratio of the water, which is you need sodium, calcium, and magnesium for that. And ideally, you know how much nitrogen you're putting and how much phosphorus you're putting in the water also. But as far as saturated paste testing of the soil, there's really not a good way to interpret that. So that is a great thing to do to test the salinity status of the soil, but it's not a good way to make nutrient recommendations. And I'm just going to answer one question that hasn't been asked yet, which is what to do if you have bad quality irrigation water that has lots of salts and you have to leach the soil. In that case, I recommend don't worry about soil testing so much other than soil testing for salinity. Just calculate the value A. Calculate how much the grass can use and then supply a little bit more than that. Because if you're deliberately leaching to remove salts from the soil and you're doing that on a regular basis, I think you might as well just supply what the grass uses.
Sorry, Micah?
Yes.
Micah? Okay,
yes,
sorry. Sorry. Yeah, another question, please. May the PGR, the plant growth regulator, affect in any way to the necessary values?
That's an excellent question about PGRs. Yes, so the plant growth regulator, I don't think it really changes the ratios a tremendous amount, but it makes the grass grow less. And whatever reduction in growth you get from using the plant growth regulators, that's going to reduce your nutrient requirement. So you can figure when you apply growth regulators, you can get the same or better quality turf with less fertilizer.
Okay, perfect. There are no more questions by now. So, well, 60 minutes just talking for an hour. Maybe in Bangkok it's let's say it's very late, isn't it?
I feel more awake now than I did an hour ago. I enjoy talking about this topic.
Of course. So, well, if you let me, there is another question if you want.
Sure.
Sorry. In Europe, where we have limited to no fungicides to assist in turf grass quality, would this affect the ratios? For example, the move is going to zero usage of fungicides.
Well, that's a difficult one because I don't think that you can really control you can't really control turfgrass diseases by manipulating the nutrient content of the leaves. It has a little bit of an effect, but it doesn't work like a fungicide. You can't put magnesium and stop dollar spot, or you can't put potassium and completely stop anthracnose. But of course, uh, the main all I can say is try to make the grass as healthy as possible and have the optimum growth rate. I think having the right growth rate to recover from disease, to grow through disease with no deficiencies, that is the goal. And so I don't think you can really do more beyond what I've talked about here, which is try to find the perfect growth rate for your location, which you never do. You're constantly trying to adjust it, make it grow faster, make it grow slower. So you're constantly adjusting the growth rate. As you're doing that, make sure that you're supplying uh, all that the grass can use.
Perfect. So that was the last one. Let me check it. Yes, the last question. Okay, so thank you very much again, Micah, for your collaboration with Campus del Césped. I appreciate it very much.
Thank you. It was my pleasure, and I'd like to thank our translator also, who I
Okay.
suppose did a splendid job.